Hi, I'm Bryan with Pioneer Builders. I'm a second-generation builder, and this channel is devoted to all things design, construction, operations, maintenance, you name it. If it has something to do with buildings, I'm probably going to be interested in it. Today we're going to talk about how a match works. Now, why in the world would we talk about how a match works? If you strike a match and let it burn all the way down, that's about the equivalent of 1 BTUs of energy, or British thermal units. It's important to understand, in my opinion, what a BTU is, because it's related to so many different things in the built environment. Mechanical systems. How many BTUs per hour does this piece of heating equipment produce? What's the BTU flow rate for different parts of the wall assembly? All of these things are talked about in terms of BTUs. So for this video, we're actually going to get into building physics. People use the term building science. Well, this is real science here. Now, having said that, a little disclaimer. I am by no means a physicist. I didn't even take physics or chemistry in high school or college. But I like to learn, and thankfully we have this thing called the internet, and I definitely took advantage of that for this particular video. So just rest assured, I did definitely get some of this information from other sources. I didn't just rely upon my own knowledge here. But I think that's important to understand, that we do have excellent sources of information that break things down fairly simply. In fact, one tip, try to find something that explains complex subjects to children. What is on the internet for elementary school kids is just wonderful. And so if it's presented simply, then we can understand it. And of course, at the end of the day, we want to be able to apply it in a practical way. So let's get right into it, and I'll take you through how a match works now. Well, first, a little disclaimer. While I lit that match, I was in a safe environment, and this video is not intended for kids to play with fires or adults to use them irresponsibly. So to get started, this is just your basic, humble matchbox. And what you have on a matchbox is this strip here. That strip has powdered glass, and then it also has something called red phosphorus. I'm going to go ahead and get reset up and walk you through that with the board behind me. Well, as I already mentioned, I'm not a physicist, I'm not a chemist, but bear with me as we go along here. So first, we have to look at a matchbox and see how it works. So you've probably done that before, where you take a match and you strike it on the matchbox. But what's really going on there? We're taking kinetic energy, and really this whole idea of energy flow could just go on and on and on. But we're taking energy that we're producing, we're taking kinetic energy, and we're transferring that. We're actually going to convert that kinetic energy, because the match head, as it rides across that striker there, that powdered glass, it now is going to encounter friction. Friction enters into the equation. So kinetic energy, friction. Now, what happens with friction? Heat gets produced. We're converting kinetic energy to thermal energy. So try just a little experiment. No doubt you know what's going to happen. If you take your hands and rub them together, we're taking kinetic energy and we've converted it to thermal energy. So doing that with the matchbox is pretty much the same thing. The interesting thing about a matchbox as well is that it has red phosphorus. So bear with the diagram, but this is basically what a diagram of red phosphorus would look like. Now what happens is, when you take that kinetic energy and you create warmth, or that thermal energy, some of this red phosphorus changes and becomes white phosphorus. That white phosphorus now reacts with the oxygen in the air and produces even more heat. And so now we have that reaction going on. And that's just about the matchbox itself. Now let's go ahead and talk about what happens with the match. What's going on there? What are the parts of a matchstick? It's pretty obvious. We have a little bit of wood, and then we have this red stuff on top. So what's going on there? What we have in the match head is sulfur. And again, bear with the diagramming. I found that online, and there you go. That sulfur burns very readily. And so now we've transferred that energy to this match head, and now that's going to be able to react with the oxygen in the air and also burn. What are some of the other sources for fuel here? Wood, yeah, that's a log that I drew. And then something else I discovered as I was doing some reading into this is there's actually wax, and then there's another chemical, potassium chlorate, and there you go. But look at how much oxygen is part of this particular molecule. Forgive me again if I'm using some of the incorrect language. We're just getting the idea here. There is a lot that goes into having this match burn. And when you do light a match, if you've ever done that and you let it burn all the way down, there's a fair amount of heat that comes out of that. So remember, the amount of heat from allowing one matchstick to burn all the way down is about the same as 1 BTU of energy, 1 British thermal unit of energy. And that's as far as we're going to go today. We just wanted to illustrate about 1 BTU of energy. But the fun thing about doing this is we get to interact with all kinds of different building science, building physics things. We talked about kinetic energy. Do you think this is the only part of construction, design, operations, etc., that kinetic energy applies to? Well, most certainly not. Just think about water running in a pipe. Kinetic energy. How about thermal energy? Well, how are you going to be heating your house? If you're using a heat pump, you're going to be transferring energy. So some pretty exciting stuff. And so hopefully, next time you strike a match, you'll remember some of these things. Maybe not all of the details. Frankly, maybe not everything I said was absolutely 100% crisp from a science perspective. But I'm a builder. And so knowing these things I find very interesting, and I hope that you do too. And in the future, we'll continue with these building blocks so that we really understand how a building works. Well, thanks for watching. I hope you enjoyed it. Honestly, even if you didn't enjoy it, I just enjoy doing the research on this. I enjoy teaching, so I'm going to try something a little bit new here. Please let me know what you think of it though. I'm not going to stop doing this because I enjoy it, but maybe there's things that I could tweak, things that I could adjust. So thanks for watching. Again, I'm Bryan with Pioneer Builders, and I hope you learned something.